Right, so that's the name of a book written by none other than Walter Alvarez. And the Alvarez hypothesis is the one which talks about the extinction of the dinosaurs. Okay, so let's get right into it. Let's talk about dinosaur extinction and how the world changed and how our view of the world changed after that event. If we haven't met, my name is Gerald Davey and I head up the Dinozone. So this YouTube channel is all about dinosaurs and some geology thrown in, and we've got a dinosaur park called the Dinozone itself. So if you're in the geographical vicinity, come and visit us. We've got a half-sized T-Rex called Marmaduke. We've got rocks and minerals and fossils and all sorts of fantastic things. And so we can't wait for you to come and visit. Visit our website. There's no www. It's just thedinozone.com and the Facebook page and our Instagram page. Can't wait for you to join us and follow us there for updates on all things dinosaur. I'll put the links down below. Right, so that's who we are. So we can't wait to share stuff about all things dinosaur and paleontology and geology and science. All right, so let's get on with the crater of doom. T-Rex and the crater of doom. For the record, T-Rex went extinct at the end of the Cretaceous, 66 million years ago. Okay, so let's crack on with this fantastic video about how the dinosaurs went extinct. Dad, I need your help. It won't be the first time, son, so what's the problem? Well, there's a layer of clay in the rock outcrop just outside the town of Gubbio here in Italy, and I'm really puzzled as to what's going on. So I thought you, being the physicist that you are, might be able to cast some light on this and come up with some suggestions. Alright, so let me tell you more. It's really very puzzling. So there's the usual concentration of forams in the rocks right up to this clay layer, which has very few, and then above that clay layer. So I think there's been some catastrophic events. So I was wondering if you could throw some light on the matter. Oh, son, that sounds interesting. Tell me more. It's all very puzzling, I have to say. And the only explanation that I can come up with is that there was some catastrophic event that caused the extinction of these forams. So I thought if I could bolt down how long it took to deposit that clay layer, then that would give us some insight as to whether this was some kind of catastrophic event or whether some other thing is going on. So that's why I'm phoning you. So being the physicist that you are, hopefully you can shed some light on the matter. Okay, that sounds interesting, son. How thick is that layer? It's about 10 to 20 millimeters. Okay, not very thick. This is what I think. As you know, we are constantly being bombarded with cosmic dust, and there's a certain degree of iridium, certain concentration of iridium in that dust. And we know the rates of deposition of that cosmic dust. That's a pretty constant thing. So what I suggest is that you go and sample that layer, put it in the laboratory, and see what the concentrations of iridium are. And then from that you can deduce how long it took to deposit that layer. All right, how's that for a good idea? Dad, that's why I phoned you. You always seem to have the right answer when I need it. So well done to you. All right, so I'll do just that. Do you know of any labs in Italy that we can use? Maybe you've got some connections and you can let me know. It's much easier to sample and put it in a lab here in Italy than it will be to ship it stateside. Thanks for the good advice. I'm off to sample a clay layer. Right, son, it was a pleasure. I'll chat to you later. Bye. And so Walter Alvarez, the son of this story, set out on a quest that was to fundamentally alter the trajectory of his life and to alter our view of the world. All right, so let's zoom out a little bit. We need some context here. Back in the 1960s, about 1965, 66, they bolted down the theory of plate tectonics. So that's the grand unified theory of geology. And it was Alfred Wegener who came up with this idea back in 1912, 1915, when the first scientific paper was published. And there's a link to that video about plate tectonics. I'll put it in the description below. But Alfred Wegener, as you may well know, spoke about, well, he didn't call it continental drift. That was actually an insulting term that British and American geologists came up with to pour scorn on his theory, continental drift. So the whole idea was that the continents were all joined together. And if you look at a map of Africa, it fits into, or South America fits into Africa. And all the continents are once joined together in a supercontinent called Pangaea. Or Pangaea, depends how you want to pronounce that. So Alfred Wegener had come up with this theory and everybody had scorned him. He died in a blizzard in Greenland, I'm not sure on the date, in the 1930s I think, and he never saw his theory being vindicated. Anyway, the evidence accumulated and accumulated and accumulated until it became so overwhelming that geologists could not deny the existence of plate tectonics, and his theory was vindicated, but he had died way too early. That new theory was being tested out now, so geologists went out into the world and looked at it through a plate tectonic lens, because the plates all collide and they jostle and one slides underneath the other and the plates collide and they throw up mountain chains and they pull apart and have rift valleys and there's subduction zone and volcanoes, and it's all very fantastic. And this theory had all been bolted down in the late 1960s and going through into the 1970s. So it was exciting times to be in the earth sciences. And where best to study plate tectonics but in these collision zones like the Alps and the Himalayas. They say Himalayas in India, the abode of snow, and the Apennines. If you go to Italy, they call it the Apennini. So I'm going to call it the Apennini. So that's the long spine, the mountain chain that runs down the length of Italy. And so Walter Alvarez, who was the son of Louis Alvarez. So Louis Alvarez was a very, very famous guy. He worked on the Manhattan Project when they built the atomic bomb during World War II. Very clever physicist. And he worked at the Massachusetts Institute of Technology. So Walter Alvarez was in Italy studying plate tectonics. Not quite following in his father's footsteps, but certainly a clever guy. He was out there in the Apennini studying the movement and the rotation of tectonic plates. And Italy certainly sits upon a tectonic plate. So Walter was using fossil and geophysical evidence in his studies, in his research on the rocks of the Apennini and plate tectonics. And the fossils that he was using were not dinosaurs. In fact, you would probably stand on these things and wouldn't know what we were looking at. They were foraminifera, commonly known as forams, tiny little organisms that swam around in the ocean in their millions. Let me show you a picture of foram. So there are these tiny little shells, and they actually evolve quite rapidly, and they settle out onto the ocean floor. So we're just going to call them forams rather than the long foraminifera. And that's why when we're having the conversation, our conversation between father and son, you just call them forams. So forams are very, very useful for geologists. And this is what the British Geological Survey has to say about them. And I shall read the quote. The stratigraphic range of some foraminiferal species is very short, and they can be used to give a relative age to the rocks in which they are found. The rocks can be assigned to foraminiferal zones, which equates with periods of time. Zones may vary in length from a few thousand to several million years. They allow correlation of geographically separate rocks, which is very important when making geological maps, exploring for oil or gas, and building large civil engineering projects on the British Geological Survey. And the geophysics were the reversal of the poles. The Earth's North Pole and South Pole switch periodically. They flip. So Walter was working his way up through the geological column, studying the fossil foraminifera until he found that horizon of clay where there were absolutely no fossils at all. And certainly above that clay layer, there was nothing, absolutely nothing. And that's what made him think, where have all the fossils gone? There had to be some extinction event that had driven that process. It's a good question. Okay, so I don't know, have you got an answer for that? Where had all the fossils gone? I'm going to zoom out even further now. So in the early days of geology, there was a war that went on between the catastrophists and the all these big words, and the Uniformitarianists. So geologists, if you could call them that, the people who first got into the study of earth science and geology. they were trying to work out how the landscape had formed. A lot of them were British geologists. If you go up into Scotland, there's some fantastic landscapes. A lot of them had traveled down to Italy, been to the Alps. They see all these amazing, amazing landscapes, and they're trying to work out what led to the formation of them. So the one theory was that, and I think it might have been coming from that Judeo-Christian biblical idea of the creation of the earth. And so they were trying to also tie in the creation story from the book of Genesis into this whole new science of geology. And there are obviously some contradictions going on there, and which they could see, and they were trying to work it out. So they came up with this idea, the catastrophists, that the earth had been formed by a series of catastrophic events. And so the Uniformitarianists, in a theory now known as Uniformitarianism, they thought that the earth had been formed in a series of ongoing minor, small, continuous events. So like a uniform processes that were happening rather than volcanoes and earthquakes and floods and all those kind of things which the catastrophists were into. And we could chuck in meteorite impacts into the catastrophist camp and ongoing processes of erosion and deposition and series of very small events leading to the formation of the landscape. So that battle took place. They scrapped it out. And to this day, geologists speak about this theory. The present is the key to the past. So if you go down and look at a river and you see the deposition of sands or the transport of sediment or the work of oceans and the waves, those same processes were at work 1 million years ago, 10 million years ago, 100 million years ago, 1 billion years ago. And so that's this whole idea that the present is the key to the past. If you understand the processes that are happening today, you can go back into the past and see the same things that are written in the geological record. You can see them in the modern day sediments, and you can actually see the same things in the ancient rocks. All right, so that's the theory of uniformitarianism as opposed to the theory of catastrophism. And the uniformitarianists won. And every geologist today is essentially a uniformitarian. All right, so well done to the uniformitarians, or maybe the uniformitarianists, but yeah, the uniformitarians. All right, but then the catastrophists got their revenge. So this is why I had to go on this little journey to first talk about plate tectonics and why Alvarez was doing his thing, looking at the rocks in Italy with no intention of trying to talk about the extinction events or any of the death of the dinosaurs. He was just there looking at plate tectonics and then zooming out a little bit further, talking about the catastrophist, uniformitarianist argument that went on. So now we can tie this whole story together, and so let's have some fun. So the catastrophists got some kind of revenge. And the uniformitarianists are still rubbing the lump on the back of their head where that rock that the catastrophists threw at them hit them. They've still got that lump on the back of their head. All right, so let me tell you why. So when Walter Alvarez got the results back from the laboratory, it turned out that the iridium levels in that clay layer were 90 times higher than what the normal background concentrations are. And he said, bingo. So something phenomenal had taken place or was going on in Gubbio. So the next question that Walter had to ask himself was, could the same phenomenon be seen elsewhere? So he went on the quest for rocks of that same age, Cretaceous Tertiary age. So if you've watched some of my other videos, the dinosaurs lived in what is called the Mesozoic, meaning middle life. So it's made up of the Triassic, the Jurassic, and the Cretaceous. And the dinosaurs went extinct at the end of the Cretaceous, and then it ticked over into what is called the Tertiary. It's changed now. You still see it in a lot of the literature, the KT boundary. The Tertiary is now called the Paleogene. All right, so Triassic, Jurassic, Cretaceous, dinosaurs went extinct, and it ticked over into what is now the Paleogene. So Walter Alvarez went looking for rocks of that age, the end of the Cretaceous. And those rocks aren't that common. To go and find exactly that kind of outcrop, that when I say outcrop, a rock, exposure of rock that you can see and visit and sample and do research on. A lot of rock is buried under soil, particularly in Europe, and to get that exact boundary is very difficult. But anyway, they found an outcrop of exactly that age in a place called Stevens Klint in Denmark. And guess what? It also had high iridium levels. So wow, okay, things are happening now. All right, so then Walter said, okay, we bolted that down. It's not just in Gubbio, it's in Stevens Klint in Denmark. All right, so the next question is, could those high iridium levels have come from another source? So the theory is put forward that maybe there'd been a supernova. So a little bit of astrophysics here. When a star eventually reaches the end of its life, it actually essentially explodes. It goes supernova, and it gives off huge amounts of energy and radiation. And one of the elements that they would find if it went supernova would have been plutonium. But they did their research and they tested all those different clay layers and they found that it was deficient. So there was no evidence whatsoever to suggest that a supernova had led to that extinction of all this foraminifera at the end of the Cretaceous. Right, so after all this detective work, we know that 1, we've got high iridium levels, 90 times the background levels. We've got rocks elsewhere on Earth at the Cretaceous tertiary boundary, Cretaceous Paleogene boundary, also with high iridium levels, that one we talked about in Denmark. And there were no fossils in the Danish example either. There was extinction there. There was no foraminifera. All right, so there's 3 lines of evidence there supporting this theory that there's been some major extinction event. So the next question is, what caused it? So they came up with this hypothesis that a massive meteorite, an asteroid, had hit the Earth at the end of the Cretaceous, that had thrown up huge quantities of dust and iridium and all this other debris into the atmosphere, and it blocked out the sun and led to the collapse of food chains and ultimately the demise of the dinosaurs and 75% of all other life on Earth. But Walter then had to ask the question, well, would an impact of that sort actually lead to that kind of effect? So he went and looked at the historical records of the largest eruption that has ever taken place in Earth history in kind of in the modern world. So he looked at the eruption of Krakatoa, as we know it in the West, Krakatau, Krakatau. So that's a volcano in the Sunda Strait, just off the coast of Indonesia. So Krakatau erupted back in 1883, and that boom, that explosion was heard as far away as Australia. And it threw vast quantities of dust and volcanic ash into the atmosphere, and it led to a global cooling, and they were very, very cold winters for about 5 years thereafter. So that study by Walter Alvarez proved that a massive kind of eruption or asteroid of that size could have affected global temperatures. And so a huge catastrophic event had shaped the planet in ways that even the catastrophists, who we met earlier, couldn't have imagined. And as the Uniformitarians rubbed the back of their heads where that rock had hit them as thrown by the catastrophists, they were forced to take on some of these notions of the catastrophists that, yes, in spite of this uniform building and modification of the planet by the small incremental little changes that were going on, the erosion and the deposition and all these little events, every so often there's a catastrophic event that really, really affects what's going on planet Earth. And in this case, the asteroid that came roaring in at the end of the Cretaceous that led to the extinction of over 75% of all life on Earth, including the dinosaurs, that was a catastrophic event. So well done to the Uniformitarians for taking it like a man and not crying too much. And well done to the catastrophists for throwing a rock at the Uniformitarianists and had, to some extent, their theory proven. Although no one was having that argument anymore. We were well over it. Geologists are essentially uniformitarian in their outlook on life. So Walter Alvarez had found his niche, and he changed the direction of his studies, and he went hunting for meteorites and asteroids and all those impact effects on life and Earth and all those kind of things. And the theory is now known as the Alvarez theory. And so when I was at university, that was all fairly new stuff too. And I remember going to a lecture in one of the lecture theatres and listening to all these kind of theories. So, the theory was, I don't know, maybe 7-8 years old. Yeah, this was kind of heady stuff. I remember this amazing story about the meteorite, this asteroid that had hit planet Earth, and how, as we've just seen, the fallout from all that ash and for the extinction of 75% of life on Earth. So that was quite an amazing theory at the time, and that is now called the Alvarez theory, or the Alvarez hypothesis. And that theory took the world, certainly the geological world, by storm, and it actually has fallen into kind of collective consciousness, this whole idea that an asteroid killed the dinosaurs. But now that we've got this whole hypothesis, this theory that's been put forward, the quest was on to find the impact. Where was ground zero where this asteroid came and punched into the Earth? And there's a story about some drill cores that got lost. But to cut a long story short, the meteorite impact site was found in the Gulf of Mexico, in the Yucatan Peninsula. And you can't really see it. There's no hole in the ground or some magnificent impact crater like you see on more modern impacts. But some geophysical work, some borehole cores from gas and oil exploration. Those cores went missing, but they were ultimately found. They found some evidence. In fact, this was part of it, tsunami evidence on the shorelines. But they also went and drilled this crater. Then they found granitic rock in the center of it. And granite doesn't make up the sea floor, the ocean floor. The ocean floor is made of basalt. So obviously this asteroid came in and it punched right through the overlying rock, the basaltic material, and exposed the underlying granitic bedrock. So the asteroid impact, the ground zero, was found off the Yucatan Peninsula, and that is the crater of doom. It's now buried under sediment and it's been eroded away. And so we know where this crater is now, so you can go and visit it if you want. Well, there's nothing really to see because, as I said, it's all been buried under younger sediment, and part of it's in the ocean, actually in the Gulf of Mexico. All right, so the Yucatan Peninsula, there's a photograph for you, and there are some of the cenotes that you see, those underground caves that actually might mark the outer rim of this crater. So there are some competing theories for the extinction of the dinosaurs, one of which is volcanic activity. So in the Deccan traps of India, massive outpourings of basaltic lavas, massive. And those rocks have been dated to the same age as the extinction of the dinosaurs. So there is a bit of a war going on at the moment between the volcanic camp and the meteorite camp, but there's also a move to amalgamate those two theories. So maybe, and I think actually Alvarez might be involved in this, maybe the impact of this huge asteroid, 13 kilometers across, caused some of that, caused the eruption on the other side of the planet in India. And that volcanic eruption and all the dust and the ash that came out of those volcanoes, those flood basalts, might have also added to the atmospheric debris, the ash, the dust that led to that. Not a nuclear winter, I want to say nuclear winter, but the darkening of the skies and the cooling, which led to the collapse of the food chains and the death of the dinosaurs. It's very complex. Geologists and biologists and all these really smart scientists are trying to work out, and it's very difficult when you're looking back 66 million years to work out exactly what went on. All right, so Walter Alvarez is now 83, still at it, and the discovery of that clay layer with its high iridium content made him think, why? What was the catastrophe that caused that, and why were there no fossils above that layer? And his chat with his dad, the very clever father, won the Nobel Prize in Physics. That was a conversation that they had, and that led to looking for more sites where they had other high iridium levels and no fossils there above in the geological record, and then looking at that supernova theory, and then the quest. And that was a bit of a race, actually. Once everybody had accepted the fact that there'd been a huge asteroid impact, there was a bit of a, way, let's see who's going to be the first to find the crater. And that crater was found on the Yucatan Peninsula, the crater of doom. So hats off to Walter Alvarez for changing our view of the world and giving us insights into extinction and the way we view dinosaurs. So that's the Alvarez hypothesis. So Walter Alvarez was a uniformitarian with catastrophic leanings. Hats off to Walter Alvarez. Thank you, Walter. And all geologists are uniformitarianists with occasional catastrophic leanings too. All right. So that's the end of my little video on T-Rex and the Crater of Doom. That's the name that Walter Alvarez came up with. He wrote a book on that and talks about the whole story from when he first found that very strange clay layer right through to where we are now in our understanding of extinctions. So I borrowed his title. Thank you for that. And I hope you enjoyed this video. Check out that video below on plate tectonics. It's a nice story. That was made for our sister YouTube channel called Rock and Sky, but that's another story. All right, so I'm going to leave it there. Until we see you on the next one, please leave your comments below. Please like, please share, please subscribe, please hit the notification button. Bing, I can hear that. Ding, okay, thank you. And because it's good for the algorithm, it's good for me, and it's good for you. You're going to learn about earth science and dinosaurs and all these fantastic things. So I don't just want to talk about dinosaurs, I'm trying to talk about all these other things, paleontology and ancient life and extinction and all these fantastic things. Being the geologist at heart, I can't just look at fossils and dinosaurs. I want to talk about rocks and all these kind of amazing things too. The exciting parts of geology and paleontology. All right, so thank you for subscribing. Right, I'm out of here. I'll see you on the next one. Bye.